Hi friends, today we are going to study about polynomials. What are polynomials and what are non-polynomials? These are the two terms which we describe and study in mathematics. The word polynomial. Polynomial means poly means many. Nomials means terms. So if you have a function like 5x square plus 2, this is known as a polynomial. If you have a function like this, 3x cube plus 2x square minus 5, this is also a polynomial. Now it contains two terms, term 1 and 2, so it is called binomial. It contains three terms, 1, 2 and 3, separated by plus and minus signs. So this contains three terms, 1, 2 and 3. So this is known as trinomial. These are polynomials, and if you have only one term, let it be 3. It can be written as 3 into x to the power 0. So it has only one term. It is known as monomial. So polynomials are the equations or the function which contains terms having a variable separated by addition, subtraction or even multiplication with the coefficients. Now what are not the polynomials? Non-polynomials. Non-polynomials are like if we have y or say f of x is equal to e to the power x. So here this variable is on the exponential of a constant, or if we have a function like this, e to the maybe 2 raised to power x, or if we have a function fx is equal to x under root. Now here in polynomial the exponential has to be the whole number. Whole number is 0, 1, 2, 3 and so on. So it has to be the whole number. So if it is x raised to power 1 by 2 or x under root, it is not a polynomial. So if I have to sum up, a polynomial is an equation which contains terms separated by addition or subtraction or even multiplication with the coefficients, but those equations are not polynomials if the variable, here it is x, it is variable is in denominator, because if we have fx is equal to 1 by x, here x cannot be equal to 0. It is not defined, so therefore it is not a polynomial. Number 2, it is exponential to a constant. Exponential to a constant. So y is equal to 2 raised to power x is again not a polynomial. Then the variable's power has to be whole number 0, 1, 2, 3, so on. So fx is equal to x into root is again not a polynomial, and fx equal to minus, let it be 5x to the power minus 3 plus 2x square or something like that. So this is also not a polynomial because power is not a whole number. So these are non-polynomials. Why we say that, why we study polynomials separately and non-polynomials separately? Why we have two different kinds of studies? Why we want to study, club them in one group and club them in another group? Because if you see, with the help of an example, if I take y is equal to 1 by x, now clearly this is non-polynomial. And if I take an example of y equal to x square, that is a polynomial. If I have to draw graph of y is equal to x square, will be something like this. Now this is y-axis, this is x-axis, so this is y equal to x square. The graph is continuous and it is something like this. Now you will visualize when I draw the graph of this. The graph of y is equal to 1 upon x, it will go like this. Now x is not equal to 0 in this case. So when x is not equal to 0, so it is not going to touch. So this will have asymptote. It has two asymptotes. Asymptote is on y-axis as well as on x-axis. If I have to draw a straight line, this graph will not touch that straight line. It will go nearer and nearer to the straight line. It will go nearer and nearer to this straight line, vertical straight line as well as horizontal straight line. In this case also horizontal and vertical. So these two asymptotes, that means the horizontal and the vertical lines, would not meet the graph. So there are two asymptotes, one is horizontal asymptote and another is vertical asymptote. So you can see the graph, it is not touching 0 and it is going to infinity, and x is not equal to 0. If you have such kind of graph or an equation, that is known as non-polynomial. So we study non-polynomials, they behave differently, and polynomials, they behave differently. Now when we talk of polynomials, we have certain terminologies, as I already explained. One is monomials. If in that equation there is only one term, we call it as monomial. As I took this example, y is equal to 3x square, it is a monomial. And if we have two terms, 5x plus 2, it has two terms, and this is known as binomial. And if you have three terms, maybe 3x square plus 2x minus 2, so it has three terms, term 1, 2, 3, so it is trinomial. And if you have four terms or more than four terms, all those are known as polynomials. So monomials, binomial, trinomial, and beyond that 4 and more than 4 terms, is known as polynomial. Now this is something about the polynomial, their graph, and this is something about the non-polynomial and their graph. The reason why we study them separately is obvious, because here x is not equal to 0, the graph and their behavior and their when we subtract or multiply, that is different. So that is why we separate them. Now here a logical question comes in the mind. If these are monomials, binomial and trinomial, then what is quadratic, cubic and linear equations are polynomials? Linear is where you have terms like this: the power of the variable is 1. That comes under linear polynomial. Quadratic is the highest power. Highest power here it is 1. So here if I take an example, y is equal to 5x square minus 2x plus 3. Although it is a trinomial, but the highest power of this is also a trinomial. 5x cube plus minus 2x plus 3. These two are trinomials, but here the maximum power, here it is 2. So this is called quadratic, where the maximum power of variable is 2. Here it is 1, here it is 2. 1 is called linear, 2 is called quadratic, and here it is 3. Though it is also a trinomial, it contains 3 terms, but the power of the highest term of the variable is 3, so it is called a cubic. So I sum up, let us not confuse monomial, binomial, trinomial with linear, quadratic and cubic polynomials. So in linear you have the maximum power of the variable as 1, as 2 quadratic, as 3 cubic. You may have an equation with monomial as x3 plus 0. So it contains only one term, but it is a cubic polynomial. So number of terms decide whether it is a monomial, binomial, trinomial or a polynomial, whereas the power of the variable, the maximum power of variable, here maximum power of variable is let us say here this is variable, 5 is coefficient, 5x the power 2, so variable's power is 2 minus 2x the power 1, this is second term, plus 3x the power 0. So 2, 1 and 0. The maximum power in this equation is 2. So we differentiate this equation on the leader. The leader is the maximum power, the highest power is 2. So in this equation the highest power is 2. We call it as, we have a separate group known as quadratics. If it is 3, we have a separate group known as cubic. So what we do, we have polynomials. So first is equations. There is a relationship. Equation means a relationship. Y or fx has some relation with x. It could be 1 upon x square, or it could be y equal to x square plus 5. So out of these equations, certain equations are not or non-polynomials and certain equations are polynomials. Out of these polynomials, we have different groups: monomials, binomial, trinomial, and so on and so forth. And if we have to distinguish these polynomials depending upon the power of the variable in this, so depending upon the power of the variable, we do not see how many terms are there. We just see the power of the maximum power of the variable. If the maximum power of the variable is 2, we call it as, it may have 2 terms, it may have 3, whatever, or it may have 1 term, but the maximum power is 2, we call it as quadratic equation. This quadratic is binomial, it has 2 terms, but if we add 1 more term, it becomes trinomial, but equation will remain quadratic because maximum power is 2. Where the maximum power of a variable is 3, we call it as cubic. So this was something about polynomials, why we have polynomials and non-polynomials separately. We study them. The reason I explained with the help of this graph and asymptotes, because asymptotes do not touch a straight line in this case. So see the graph, it never reaches 0, it goes to infinity. Here also it goes to infinity, but it touches this point, it never touches. So that difference you can very well visualize, and their behavior, the equations, they are studied, therefore they are studied separately because of their equations. And when we do multiplication and draw the graph, so they behave differently. So this was something about the polynomials. If you are interested in knowing more, you may contact me at 94170425547. You can discuss with me, drop a message on my WhatsApp number. I am available online and it would be free of cost. For any discussion more on this topic or any other topic. Thank you.